Sauce here. This is a video lesson on congruent and similar. Congruent and similar are concepts that are very useful in geometry. They talk about a relationship between shapes. Congruent means same shape, same size. But I put this definition in quotations because it's informal. When we get to geometry, we have a more sophisticated way of defining what it means to be congruent. But this is very useful. Same shape, same size. Let's give an example. I'm going to draw 4 points and connect them to make sides of a shape. I'm going to make another shape by drawing points and connecting the sides. If I had a way of measuring the sides and angles of these shapes, and I did so and confirmed that these two sides are equal, I could use notation. One tick mark in the middle of the side means that this side with the same tick mark is the same measure. And I could continue to measure these sides and show that the measure of this side is equal to this. The distance of that line is equal to this, and these sides which correspond, I might show are also equal in measure. I could do the same thing with angles. These two angles and these two shapes correspond. They're in the same position. I could use an arc to show that they're equal. These two angles with a single arc is notation to show that those angles are equal. I might go and find that all other corresponding angles are equal, which would mean that these two shapes are the same shape and the same size. All corresponding angles and sides are equal. These shapes are congruent. If I put the symbol for congruence in between, which is an equal sign with a tilde above it, then this says the relationship between these shapes is that they are congruent. They're the same shape and the same size. And the symbol for congruence, again, is an equal sign with a wavy line or a tilde above it. Let's talk about what it means to be similar. Informally, so we'll put it in quotes, similar means same shape, different size. And it's in quotes again because this is informal. The formal definition of similar is a little more sophisticated and useful for understanding a deeper relationship between shapes that are similar. But for now, let's give an example. I've drawn a right triangle. It has a right angle in it, and I could use arcs to highlight these other two angles. If I had another triangle that had a right angle in it, and the other two angles were corresponding and equal to the first, then these two shapes are the same shape that have equal corresponding angles, but they're not the same size. The measurements of their corresponding sides are different. If I could show that these two shapes were the same shape but different size, I could say that they are similar and use the symbol in between them to show that relationship. This triangle is similar to this. Notice that in our first case where we showed these two shapes to be congruent, these two shapes are in the same orientation. They line up. But they'd still be congruent if I took one or both and I rotated them or moved them around the page. What's important about congruence is not where they are on the page or if they're rotated, but that the corresponding angles and sides are all equal. In this example, I could imagine that I rotated this triangle. The corresponding angles are equal. The sides are not equal. Later we'll learn that they're proportional. But it doesn't matter that I might have rotated one or both of these shapes. They're still similar even though they don't line up like these.